Welcome to Lesson 8 in Saxon Math Course 3. Today we'll be talking about perimeter and area. Our objectives for today: after this lesson you should be able to find the perimeters and areas of rectangles, and understand floor tiles as a model of area and baseboards as a model of perimeter, determine how changing the dimensions of a shape by a factor changes its perimeter and area, and find the perimeters and areas of complex shapes formed by multiple rectangles. To review from your last lesson, we talked about rates. Rates are usually some measure of distance or capacity over time, so miles per hour, feet per second, gallons per minute, that kind of thing. We talked about the measures of central tendency, mean, median, mode, and range, and how to find those. So let's talk about perimeter first. Perimeter is the distance around an object. A baseboard. Baseboards, if you're not familiar with those, are usually small strips of wood that run along the floor in a room. They're usually decorative, or they hide a little space between the flooring and the wall. But that would be an example of perimeter. If you needed to figure out how many feet of baseboard trim you needed to put on the walls in a room, you would be finding the perimeter of the room. So to find that, you add up all the sides of a shape. If you're talking about a rectangle, instead of adding up all the sides, you can use the formula P for perimeter equals 2 times the length plus 2 times the width. And we can do that because the length, both lengths on the rectangle are the same number, and both widths on a rectangle are the same number. So that just saves you a little time with adding. Area is the amount of space inside a flat object. So if you were tiling a floor, that would be an example of area. And I know we talked about this before, but say your tiles are a foot on each side and they're squares. Area is always going to be a measure squared. So if you were tiling and they were square feet, it would be feet with a small raised 2. That's square feet. That's how you would label that. You find that by multiplying the length and the width of a rectangle. So area equals length times width. If you double the length and width of a rectangle, so here's an example. You have 2 rectangles. One rectangle is 4 feet by 3 feet. The other rectangle is 8 feet by 6 feet. So notice we doubled the length from 4 to 8, and we doubled the length from 3 to 6. If you do that, your perimeter is also going to double. So if the perimeter of the first rectangle is 14 feet, the perimeter of the rectangle that we doubled the dimensions is 28 feet. 28 is double 14. Something different happens with area though. Area actually gets 4 times larger when you double the dimensions of a rectangle. The area of the first rectangle is 12 because we did 4 times 3. The second rectangle is 48 square feet because 8 times 6 is 48. So 48 is 4 times the size of 12. Perimeter and area of complex figures. Perimeter is pretty easy, even with complex figures, because you're still only adding up all the sides. Sometimes you might need to find the missing side lengths first. They might not give you all of the side lengths, so you'll have to use what you know from what they've given you in order to figure out those missing numbers. And for area, for now, the complex figures that we're going to look at are made out of a couple rectangles put together. So there will be a few different ways that you can split those into 2 separate rectangles, and then you would do length times width for each rectangle and then add the 2 areas together. So let's look at an example. Here's a complex figure. This is how a lot of them will look, kind of an L shape. But they've given us 4 of the side lengths, but there are 6 sides on this shape. So in order to find our perimeter, we're first going to have to figure out what this is and what this is. So let's use what they've given us. If we know that this is 3 feet and this is 3 feet, then this side right here is just those two put together. So that means that this length would be 6 feet. All right. Now we also need to find our short side at the end there. So if this whole side is 11 and this side right here is 8, then this side right here would be 11 minus 8. 11 minus 8 is 3. So this one's 3 feet. Now that we know all of our side lengths, we just add them all up. So we've got 3, how many 3's do we have? We've got 3 3's, so 3 times 3 is 9. I'm sorry, I don't know why I'm multiplying. We're adding 3 plus 3 is 6, plus 3 is 9. Then we could add our 9 and our 11 is 20, plus 8 would be 28, plus that 6 would be 34. So the perimeter of this would be 34 feet. Now, I'm just going to get rid of these darker lines here. When we're talking about area, remember we're going to split this into two rectangles. So I'm going to imagine that I split it here. So now I've got this rectangle, and then I've got this rectangle. So see, I've got 2 different rectangles. Then all I need to do is figure out what's the length and what's the width of each one. So this top rectangle here has a length of 8 and a width of 3. 8 times 3 is 24. And the bottom rectangle, this one, has a length of 6 and a width of 3. That would be 18. And then I just add them together. And I find out that my area is 42, and remember, square feet. So 42 square feet would be the area of this complex figure. That's all we've got for today's lesson. Make sure you do your practice problems, type up any questions you have in the discussion section, and we'll talk about them next time. We'll see you in Lesson 9's video.